So we're going to do a full review on rotational motion. And we have a coin right here, and it's glued down to this spinning wheel. Now what we want to calculate is the period, the frequency, and the acceleration of this coin. So to calculate the period, what you want to do is you want to take the amount of time over your turns. Period is a unit of time. Now frequency is just going to be the inverse of period, because notice this is turns over time, where this is time over turns. Acceleration, you need to have your tangential velocity, and you need to square it, and then divide it by the radius of your circle. Now notice here, tangential velocity is going to point tangent to the curve. Now centripetal acceleration, on the other hand, actually is going to point in. So this right here is going to be your vector for centripetal acceleration. So let's go ahead and assign some numbers. First off, we're trying to solve for the period. And notice that we have a time of 30 seconds. It takes 30 seconds for the coin to complete 10 turns. So we have time and we have turns. So what we can do is we can use this relationship here to calculate the period. So we can take our time, which is 30 seconds, over our turns, which is 10. Notice how we have 30 over 10. And what we can do is divide those two, and that's going to give us 3 seconds. So the period of motion is 3 seconds. And what that means is that this coin right here is going to cycle all the way around the wheel after 3 seconds. We're going to calculate frequency. We're going to do this using turns over time. And we have 10 turns that are completed in 30 seconds because that's given in the problem. We complete 10 turns, so that's going to be our turns. And then we complete this in 30 seconds, so that's going to be our time. So we have 10 over 30. Now 10 divided by 30, that will reduce down to 1 over 3. And your unit for frequency is going to be hertz. Also, something to keep in mind is 1 divided by 3 on a calculator is the same thing as 0.33 repeating. So 0.33 hertz approximated to the second decimal place is going to be the frequency of motion. Finally, let's calculate the acceleration. And the acceleration is going to be a little bit tricky. So first off, you need your acceleration equation, but notice that we need to find velocity using this equation here. Notice that this is just saying that velocity is circular distance over circular time. So we can take this equation and we can plug it into the top of our function right there. Now, if we square every term inside, you're going to end up with this. So here we have 4 pi squared times r squared all over t squared. We just took everything in this term and squared it. From here, you can actually cancel one of your r's. And now from here, you can just get your final equation. As you can see, we have 4 pi squared times r over period squared. So if you just like to memorize the final equation, this right here is an equation that will directly give you your centripetal acceleration. We have our radius right there, which we can plug in for our radius here. And we also have our period calculated from the last problem. Our period was 3 seconds. So in this case, we can plug everything into here. But one thing we'll want to do real quick is convert the centimeters to meters, because we want our units to be in meters. There's 1 meter per 100 centimeters. So if I cancel these centimeters right here, I'm going to get 50 divided by 100 is equal to 0.5 meters. So I can take this and I can plug it in for the radius, and I can take this and plug it in for the period. And when I do that, I end up with this. I'm going to end up with 2.19 meters per second squared. And that is going to be the centripetal acceleration of the wheel.